So for the protocol, I started the record now, and we can start with this part. Yeah, as I said in the introduction, this part 2 will be the biggest and I guess the most intense part of this seminar in terms of work. But yeah, it will also be fun, as you will encounter later. So as an introduction, I want to tell you briefly about sound synthesis and some very general aspects about sound perception and how to produce sound. And then we will do a little pure data workshop where I give you an introduction in pure data, and then then transitions to the exercise in the end. So the first question, what is sound? By the way, I have my, when I record, oh no, I can actually stay in Moodle because it, sorry, I'm a bit confused. Yeah, oh, I can stay in Moodle because OBS records my slides anyway. Okay, I think it's fine because now I can see your comments as well. If you have any comments or questions in the chat, or again, please use your microphone to ask as usual. But now, what is sound? So I'm pretty sure you all have an idea about what a sound is. But from a sound generation point of view, there are 4 ways to vibration is very good. The sound is in physical terms, it's vibration through the air, like waves vibrating through the air create sound. Totally exactly, which is the first way we can see here, which is the natural sound at all. So natural sound is just any movement through the air. You can remember from the first lecture where I told you about the string, the monochord, where I told you that when you vibrate the string, when you pull the string, it vibrates and moves the air, which is creating a sound. That is the very simple example of natural sound. Another simple example would be our voice. So the moment I'm speaking, I'm creating natural sound. But you receive this sound virtually, digitally, which brings me to the other ones. Well, we have, of course, synthetic sound, which could be analog and digital. So synthetic sound, analogically spoken, is like sound produced with electronic devices, like an oscillator, for instance, or electric guitar. And then we have synthetic sound, which is digitally produced. That's exactly what you now receive. Like it's my natural sound. I'm speaking here within this room. Convert it to digital sound, and you receive that sound through your speakers. But it's again transformed to natural sound, because at the moment the sound leaves your speakers. It's again more or less natural sound, because that's the part from the speaker to your ears, where again it goes through the ear. And yeah, then we have a very special way to use sound, which is sampling. So sampling is more or less recorded natural sound, or any form of recorded sound, which is either used in analog or digital, or either used in analog systems or in digital systems, where you reproduce that sound. A sample is more or less everything that is recorded in some way. So you wouldn't say to a CD or to an MP3 that that's a sample, like to a song, but in fact it is recorded music. But a sample is usually more like a snippet of sound, like a couple of seconds, which resembles this some sort of sample idea of having recorded sound in short chunks. So these are just brief. I'm sorry, these are just brief examples of the various ways sound can be generated. And another important aspect of sound is, if not the most important aspect of sound, is the perception, like our human perception of sound. And we can perceive sound with our ears, like in principle. I mean, we can perceive sound with our other body as well, as like we can feel bass sound, for instance, or we can see a vibrating membrane of a speaker. But in fact, usually we perceive sound with our ears, and that's the intended way to perceive sound. And perceiving sound has two qualities. One is the physical, biological, and one is an aesthetical. And the physical or biological perception of sound is clearly defined, as you can see with this image on the left. So our human hearing system can perceive sounds that are somehow between 20 hertz to 20,000 hertz, roughly. So that's the range we can hear. To give a very brief outlook, as this whole lecture is not about what's behind sound and so on, but we just use it. But I like to give some very brief input here, because some of you probably haven't heard about these terms at all, so it's quite important to hear that at least once. So I guess you all know the concept of hertz. So hertz describes how fast something is swinging through the air, or in fact not only through the air but swinging. So 20 hertz is very low swinging, like a wave that has very long intervals between the amplitudes, and 20,000 is very quickly altering. So it's 20,000 20,000 swings per second. So that's the range we can hear as humans. And music, as you see in this diagram, is usually somewhere in between this range. So in music, you like intentionally mix, and that's what the mixer or the master process in studios does, that you reduce the frequency range of the recorded music at particular ways, because as you see here, for instance, that the low frequencies, or especially higher frequencies, are somehow reduced in recorded music, for instance, to give it a sound range of frequencies that is like played back in recorded music. So someone is typing. Is there a question? So at 20,000 hertz, at 20 hertz, you directly go from inaudibility to threshold. No. Where was the threshold of pain? No. The threshold of pain is the sorry, I haven't mentioned the sound level, which is on the left axis. Sorry, the horizontal axis is the frequency, which is the hearing range, and of course another second important aspect of sound is the sound level. So with the sound level is not the amplitude of the wave moving through the air, but it's the energy that is used to produce this wave, more or less. And this is measured in decibel, like a dB, which, important to know, is an exponential curve. So 40 decibel is significantly more than 20 decibel, so it's not double, it's significantly more. So just to give an impression, like the usual hearing is like the usual sound is 20 decibel or something like that, and a lawnmower, for instance, is about 80 decibel, so something like that. And I think like a jet engine is about 120 and 100 like decibel, and that's why you see here's the threshold of pain. So if you would stand beneath an airplane engine, for instance, or a jet engine without ear protection, it would really cause damage to your ear, because it causes not only pain but damage. Because that's why here in this diagram it says threshold of pain is near 120 decibel. So yeah, and beyond that, it's a severe damage of your hearing. Isn't the decibel scale? Yeah, logarithmic. Sorry, yeah, not exponential. It was well, the logarithmic. It's yeah. I think it's both. It's both actually. Yeah, but yeah, that's the idea behind this hearing range and the relation between decibel and, well, yeah, it does grow quickly in either case. Yeah, exactly. So as I said, I don't want to go into this deeply. If you're really interested in that, there is lots of literature out there to read.